This drone right here is changing the battle space forever, and it has been for almost a year now. It is totally RF silent, it's unjammable, invisible to most common detection mechanisms for drones, and is under $600 to build. What makes this drone so special though? It's this canister that we see right here. It is a fiber optic tether. And we're going to break down what this tech is and how it works and how it's changing the battlefield. Let's get into it. What we have here is a massive 10-inch drone. I felt pretty good walking around with 8 inches, but I was told that that's no longer the new deal. 5 inches is what it seemed to be average online, but ever since 2022, 10 inches seems to be the new norm. So what we're using with these drones is this fiber optic container, right? Everything on this drone is the same as it would be on every other drone, except it has this container on the bottom. And this container has, in this particular case, this has 2 kilometers of spool. I also have some other spools ranging between 2 kilometers to 5 kilometers. I don't have any of the crazy 20 kilometer spools. You can pick these up from China, actually, and that's where I got all mine is from China. But how it works is you have these cables back here, and they connect to the controller board up here, and then you have a fiber optic tether out. So this sends our commands, this sends to how to fly the drone, this sends video out, and it can send other telemetry data as well. But this provides an uninterruptible, high-quality video that can be leveraged, and it is being leveraged. It was first leveraged by Russia, though Ukraine, to their credit, I guess, I don't know, they didn't go with it, so maybe not to their credit, they're using it now, but in the early start of the war, they were made aware of this technology, but they decided not to go with it from reports that I've read. Whether that is fully fleshed out or what the truth is on there, I don't know. I wasn't in those meetings, right? But Russia popularized this technology right around where we're at right now, but in 2024. And they've just been dominating the drone space with it. Now, Ukraine is using it as well, and it has been a game changer. So in the typical world of, sporadic warfare or advanced warfare, what we'll have is we'll have EW. So that's electronic warfare capabilities. We'll have signals intelligence. We'll have direction finding, right? All these different types of items that we can use that deal with the RF domain. But this drone, this actual package on the bottom, eliminates all that. So we can't direction find these drones through typical RF means. And RF is radio frequency, in case anyone didn't know. So we can't direction find them. We can't detect them with our typical means of detection with RF. And it's not because they're operating at a different frequency, it's because they're just RF silent, which is what you want, right? Signature reduction is the name of the game. And especially when we're moving into things, we're 5th generational warfare and into 6th generational warfare, Ukraine and what they're doing, they're still fighting like a 4th generational warfare fight, right? So this is a game changer in that. And even outside of 4th generational warfare, this is a game changer in 5th and 6th generational warfare as well. But we have these cables, they go to this board, we transmit data out, and then obviously this is a one-time use type of item, right? So it is a one-time use drone. You can't spool up the fiber back into this and make it do another mission, right? You can use it for reconnaissance, but a lot of time when they're being used for reconnaissance, they also have a secondary option or a secondary objective of destroying what they're doing recon on, or destroying a part of it, or causing some type of disruption with it, right? And they do that by adding another part that I don't have added to this drone because, laws and stuff like that. But with this, we can't do standard attacks against it. Sure, kinetic attacks work against this. So, shooting it out of the sky. There are some more advanced stuff that's coming out. So UK unraveled or revealed one of their more advanced EW capabilities where they just hit this with high energy RF pulses, and it scrambles up the little computers inside there and causes it to crash. As well as, the US releasing their laser tech, right? But that's not widespread. These aren't solutions that are everywhere in the battle space now, right? These are our fringe solutions. So when we try to use our old techniques, right, and what I have here is some artist renditions of jammers that I found on the side of the street, right? Artist renditions only, non-functioning, of course. This is what they would look like. This is an artist rendition. But using these right here, how we would typically take down drones, we can't use them anymore. So we have to evolve. And what's being done is, Ukraine is using other kamikaze drones to go against these drones, right? But before we dive a little bit into this canister and stuff like that, let's see some footage that we've actually seen, right? World War III is televised. So let's see what that looks like when we have fiber optic drones being used in the battle space right now. All right, let's talk about how this works. So this canister that we have right here, again, fits about 2 kilometers of spool on it, right? It has the connector right here. So this would go to, the little pigtail would go to the drone. It tells you, when it has power, when it's data, has video and communication link. These are little LEDs right here that will let you know that those are working, or at least it's getting some type of transmission on those. And then it has this tether right here, and this tether just pulls out gently from the back of this nozzle. And there's a few different nozzles that you can get depending on the manufacturer that you go with. I found that this nozzle works pretty well. I've only had, these from 2 different manufacturers, but this one and the other manufacturer has switched over to a nozzle like this, where it's more rounded and such. But then it communicates to this controller board right here. When you buy these online, you have to buy this, and then you have to also buy the controller board, which is separate. So just a pro tip on that. You can buy them as a kit, right? They charge a lot for this controller board. And I was going to look into how it works and what it's doing. Obviously, it's taking fiber right here on there, converting it, and then it has all these chips. But these chips are actually laser and grayed off. This center processor right here is actually looks to be wiped off on that. But I have not completed my reverse engineering of this yet. So look for that in a later video to really understand all the protocols that are going through this and what it's actually doing here. But then what it does is it has this controller part right here. And this will communicate to your controller. So you can hardwire your controller in here, like I have this one done. This is actually very ghetto-like in its configuration. I'm looking at better ways to do this. But a lot of people, what they'll do actually is they'll get like this is a Radio Master Micro. They'll just they'll get the wires needed for that, communicate with that, and then just have the radio be communicating with this. Now, we don't need necessarily video out from this because we could just use this BNC for that right here. So on that, this little board itself, they ask for a couple $100 for it. It is fairly well constructed. I like that. If you want to take it apart like this, you do have to desolder the on-off switch. It's super easy to do, though. and then you can play around. I've played around with it. Like I said, I'm trying to figure out what all these chips are. I haven't spent a ton of time reverse engineering them yet. I've only spent about a half hour so far, but a few more hours of that, I'm sure I can get this whole thing laid out, and I'll give an update once I have that completed. It is low on my priority list though, so if you want to see more of that, drop a comment in the comment section. Let me know that's what you're interested in seeing. Or if you want to see something else and you're more interested in that, let me know that as well. While you're at it, make sure you like and subscribe if you're enjoying this content. But this controller right here, it's powered either through a XC60 connector, like a drone battery, or a Sony L battery, and doing a lot of stuff with video. Obviously, I have a lot of these laying around, so that's how I was powering this particular board when I was using it. And since I don't have a 107 here in the US, I was letting my friend fly the drone, of course, and he broke one of the fiber optic cables with it. I don't blame him. I take full responsibility for it. But yeah, so that's how that particular part works, right? Now let's see what's on the inside of this container, though, right? Because all we see is a little connector, and then here, let's see what that spooled fiber optic connection looks like, and why it is changing the battlefield so much. All right, now that we have this protective cover taken off, we can look at what's on the inside, right? So we have this rolled fiber optic spool, and it does have like some type of glue material on the outside of it as well, and that's just to keep everything in there nice and tight. When you are flying, two things about this that I didn't cover beforehand. When you are flying with this, the first like 200 to 400 meters that you're flying, you need to fly fairly conservatively. So keep it around, 25 kilometers per hour. And when you're installing this, now I just had this quickly zip tied on, which you can zip tie these on. That's how we've flown with it beforehand. But when you install it, what you want to do is actually install it at just a slight angle. So using a spacer right here, and that's so that when it is tilted up, what you don't want is this part right here to be tilted up at a steep angle. So you angle it slightly down when you install it, so that it can be more horizontal when the drone is actually flying, right? So just pro tips that we didn't cover beforehand, but we have this spool. You want to fly, 25 kilometers per hour, the first 200 to 400 meters that you're actually flying with this, depending on how big the spool is. But inside the spool, you'll see that it has a secondary fiber connection right here. It actually connects to this control board that sits inside this spool area. It just goes in right, bam, just like that, right? It's got two little tabs that we can push in on and have it control. Actually, it goes the opposite way, like this. So this is how it sits in the spool itself. We take it out. I took this little cover off right here. As you can see with the board, though, it looks very similar. The chips look very similar to these chips right here that we have. We do a comparison between the two. And again, these are also laser etched off on the board itself. So Chinese manufacturer obviously doesn't want you reverse engineering this or having some other manufacturer reverse engineer it and then make it for cheaper. I am taking a look into this so that we can figure out more about it, right? But similar concept, this is what is being fed out. This is where our board on our drone itself will be connecting to. And it uses this pigtail. I have one of these pigtails right here. So this one hasn't been connected to anything. When you do connect them, you actually have to cut these off because these are actually little clips. So cut them off, just strip it a little bit, and then solder it onto your board. But this just plugs in like so. If we were to actually plug it in, there we go. So that just plugs in perfectly like so. And this spool, like I said, can go to 2 kilometers. If we look at it, there's space for more kilometer spacing here, so this can go up to 5, I believe, with this type of spool on there. And it does cost a little bit more. The price difference is not huge. I think I paid like $125 more for versus my 2-kilometer ones versus the 5-kilometer ones, right? Now, when you get to the 20-kilometer ones, you're paying, $1,400 for a spool, basically, which does get really pricey. And since I'm not trying to use this for anything, except for I wanted to know more about this tech because I was seeing it, I went with the cheaper options there just to play around with this, right? The fiber can break. Like I said, that's happened before to us. It's actually a little bit more resilient than you might think it is. We actually did a barrel roll with the drone while it was tethered via fiber, and it worked out just fine. But if you do get it snagged on some trees and it does not allow you to have enough slack or it pulls and gets stuck, you will break the fiber and you will lose the drone, which is similarly to what happened to us. Now, how are these flown usually during war? So these are usually flown on gravel roads or on roads, or they'll be flown, in the very beginning, they were being flown on clear paths low to the ground, so 6 to 15 feet from the ground, and just flying. Now, a 10-inch drone is extremely loud, so it can be, heard, but by the time you hear it, it might already be too late. So, and a lot of times when you hear like a drone sound, what do? You look up in the sky, right? You're like, oh, hey, what was that? You don't usually look towards the ground. So that was a technique that was being used. That doesn't mean that's the only technique that's being used. I have seen videos of these where they are flying high and then they come down and crash into something, right? But usually where there's not a ton of trees to where the fiber optic gets snagged up on, right? Or not a ton of bushes, just more cleared area that it can fly freely on to do, what it does to its intended target. But this is what it looks like on the inside. So if you ever want to see what the inside of these look like, now you know what it looks like, right? This container, it's just a plastic container, and nothing special about that. They have some that are like fiber optic. There are some that are like carbon fiber instead. Doesn't really matter what you have on it. What matters is you have a smooth bell shape on the outside right here, and then you have a good fiber optic cable here, a tether. So how is this, again, changing the battle space? Well, you can't jam them, you can't detect them, so it becomes extremely difficult to fight against them. And that's what a lot of people are finding. Ukraine is proud because now they can detect them either with traditional, or modified radar, as well as sound detection, and then they can send kamikazes to it. But it's still a huge problem, such a huge problem that Ukraine was like, oh, wow, we should start using this. And then they are now using fiber optic drones for kamikaze missions as well. So they are changing the battle space. If you were to ask me, when this war started, how do you make a drone that is impervious to RF jamming or detection? A fly-by-wire type system or a tethered system, since this isn't really my space, warfare is not necessarily my space. Building the tools for warfare is something I've done before, but, I wouldn't have thought having 20 kilometers of fiber optic cable hooked up to a drone would be the answer, right? My domain is in the RF space, so I would try to come up with a RF answer. And nope, don't need that. That's too complex. Just use a tethered RFID or RFID, mixing up my domains now, right? My expertise in physical and RF going into blending together there. But taking away the RF capability or the RF component and making it a fiber optic component is just a game changer. What we're doing here is just looking at the technology, understanding it a little bit more, seeing it, right? There's more and more videos and more headlines about these things coming out. And that's why I wanted this. I wanted to be able to take these apart, see what the inside of it looks like, show you what the inside of it, because I haven't really seen a lot of videos that have just, described the inside of it, just so that you can get a better view of what these solutions, this fiber optic solution that is being used right now in the war, what it really is, what it does, and just how simple it is, right? So I'm going to show a few more drone footage videos. We were going to shoot some video for this, but it's been pretty terrible weather for where we're at, and we didn't have any good video for when we were testing this out beforehand with the other spool before it broke. So we're going to use some of these videos to show what it looks like in a real in-field use of this particular technology. With that, thanks for your time. Thanks for stopping by. Stay legal, stay safe, keep hacking.